This is a lecture for assignment 7. Assignment 7, we're going to create the full assembly model for everything that we have up to this point. So I'll call it preliminary assembly because we don't have all the components yet. So primarily what we're going to do is combine the sub-assemblies that we've created right now. So we have the front forks, we have the swing arm and the rear axle unit, we have the jack shaft sub-assembly, we have the frame sub-assembly. And also have the engine, which will have you put the torque converter, put the CVT on that, and that'll be like a sub-assembly as well. So here, basically, this is how you would perform this. I would create a new assembly model. So insert and mate each of the sub-assemblies. So we'll start with the frame, and then add the next sub-assembly, get that mated, add the next sub-assembly, get that mated, and so forth, until you get the full assembly created. Now some of the parts are going to have to be modified as we go, and we have to create a few more parts for sure because we don't have everything ready. For one thing, you're going to need a motor mounting plate. So what I did was just make a blank plate that fit inside the frame rails. So measured the distance between the frame rails at the bottom, made a blank plate, mated it to the bottom of the frame, and I think I used the center line of the tubes actually on the bottom. And then later, after I figured out where to put the motor, I came back in and created the mounting slots so you can mount the motor and also have some adjustment for the chain. One thing we'll have to do is make an adjustable mount for the jack shaft. You're not just going to weld the jack shaft assembly to the frame because then you don't have any adjustment. Also, it's really difficult to make sure everything can be perfectly aligned to just take that unit and weld it together. There might be a problem with the bearings being out of alignment or so forth. So we'll create that sub-assembly and then we'll create some mounts that go on the frame, and those mounts will weld to the frame. There are probably most likely going to be some modifications required for the swing arm because we made that in a vacuum sorter. We designed it the way we wanted it to look, but now we're going to have to make sure all the parts fit together. And it's possible you might have to modify your frame a little bit, especially near where the jack shaft assembly goes. I ended up having to make just a couple of, I extended the length of the frame just a little bit to fit everything in. So hopefully it's nothing too major. Once you get everything assembled, I'll have you check the alignment of the front and rear tires, and we'll have to adjust to make sure that those are correct. We'll also check and correct alignment of the sprockets to make sure that the chain's is going to line up on all the sprockets, and then we'll create some drawings from the assembly. So start with your frame sub-assembly, so you should have it done to this point. You want to make sure you have the frame neck on there and everything, all the parts are mated together correctly. So that's the first thing I would do, is insert that into my new assembly. The front forks. Now you can do the front forks now or later. It's the easiest part of the whole thing to mate, so that's really up to you. I went and put the bearings on there, so all I had to do was mate this to the steering neck. Put a concentric mate with the steering neck, and then I put a mate on I think the underside of this plate to the top of the steering neck. That's all you needed. Now the jack shaft, we'll have to do a little bit of work here. A couple things I did. If you remember, my jack shaft was very square looking. I came in and put a radius in here. I tried to match that frame radius as close as possible. So since I have the frame built now, I just looked at what this inside radius, not the center line radius, and then I tried to match that closely. It doesn't have to be exact. So that way you'll have room to slide this, and that's the idea. We want to be able to move that jack shaft assembly back and forth to adjust the tension on the chains. So what I did was then make a little bracket. So again, I measured that inside radius of my frame and I just sketched a little part. I had no idea how big to make it. I came back and modified it several times to allow that. Now that'll be welded to the frame, and then this jack shaft side plate will be bolted. There'll be 2 bolts here, and the plate here is slotted, so you'll be able to move this back and forth. So you're going to need to do something like that regardless of your jack shaft design. You can't just weld that to the frame. Okay, so you will have to create these little brackets, which shouldn't be that difficult. Remember, we're not welding these jack shaft side plates to the frame. For the swing arm then, that's a pretty easy mate. Just do the center line, so do a concentric mate there, and then the end of this, and this should already fit into your jack shaft assembly. Oops, there. again, you may have to modify that a little bit depending on how your jack shaft mounted up to the frame. I was going to show you that before, but let's just keep moving. Let's see. Probably going to have to make some revisions because what's going to happen now, and we're not going to know for a minute, when you mount all this together, now we have to go in and check our alignment to make sure that the sprockets are going to line up. I went ahead and put the CVT on to the engine. Now I realize there's several different sizes of CVTs, and the one we started with, the one I gave you originally, was actually kind of large. I don't think we're going to use that big of a one. So there's a new drawing that I'll give you, and you can make a new model of that CVT. The other thing I did was add some more details so that you can have a place to like line up your sprocket. So that's going to simulate the sprocket. And what I did here was when I mated this CVT, I just mated it obviously on the shaft, concentric onto the shaft. And then I left about a half of an, or not about, but I left a half of an inch spacing between the motor and the back of that. So again, I decided to make a better model, and what I did was make a cutout here, and then I used a 2-inch diameter. So simulate of the sprocket that's going to drive the jack shaft is a 2-inch diameter, and I think I made it like 3/16 thick or something like that. Yeah. So you can use that to line up your jack shaft sprocket. So you're going to want to make a new model, something that looks like this. It's actually, this one's 8-inch from center to center. I think that other one might have been 12. It's way too large for the engine that we're using. Okay, so now you should have this assembled to this point, and what we want to do is look at the alignment of the tires. If these tires don't have the same center line going front to back, this vehicle would be very, very unstable. It would be very difficult to ride. So we're going to want to check that and make any revisions that we need to fix that. So this is what I'm talking about. What I did was put it on a drawing sheet. You could do it on the model, just do work planes. I just put it on a drawing sheet, did a bottom view of it. Make sure you're looking, that it's an ortho view, you're looking directly at the bottom. And I drew a center line on this tire, drew it all the way back there. And I just sketched that onto the drawing sheet. And then I did a center line for the rear tire. That's the green one. And then I measured the distance between those. And in my case, it was 0.33 inches, which is kind of significant. Again, that would make this vehicle very unstable if these center lines weren't the same. So then you're going to have to make some adjustments. Now the adjustment to make is in the swing arm, nothing else. The swing arm does not have to be symmetrical. The rest of this vehicle should be symmetrical around that center line as much as possible. So what I ended up doing was just modifying these mates. So these two tubes here, I shifted them both over by that 0.33 inches. So the way I had these mated, I had a plane through the center of the tube here, and then I had a plane that I had offset off of the center of this tube, I think. And all I did was change where that plane was located. So it shifted that mate over, and same thing here, shifted that mate over. There's lots of different ways to get there. You have to go in and break that existing mate and then create a new one to move those. And it should shift everything over. Now it's possible, depending with your mates, you may have something weird happening with the other components. You have to go in and check those. You may have to fiddle with those mates a little bit to get everything back to where it should be. Mine worked out pretty well. It wasn't too difficult. Now after you've got the tire aligned, so the front and rear tires are now aligned, we want to make sure that the chains are aligned. So remember, we're going to have two chains. This is a little hard to see, but here's the chain coming off of the CVT, and it's going to mate to that first sprocket on the chain. Make sure that lines up. If not, what you have to do is modify that spacer, and that's all I did was change the width of that spacer and then remated that side of that sprocket. So I know that that one's lined up. Now remember, the bike's upside down. Let's see, same thing here. You want to make sure that this second sprocket on the jack shaft lines up perfectly with your driven sprocket that's on your rear wheel. So same thing, I had to just modify this spacer a little bit and bump this sprocket over to, again, because we moved everything when we shifted these two tubes here. It also messed up our alignment there. And previously we didn't have the motor on. Now remember, with your motor, when you put that on there, make sure you allow the motor, don't mate it so that you can't move the motor side to side, because that's going to be really critical that you have alignment there. So now your frame should look something like this. all the major sub-assemblies are on here. Again, now that I knew where the motor was, I went in and added some slots there. You can see my jack shaft brackets. Everything lines up pretty nicely. Now we still have a few things to add to it. We've got to add foot pegs and handlebars and a seat, and we'll simulate some chains on here to make sure we don't have any interference. We'll need a bracket for our brake rotor or brake caliper, and I don't know, maybe a few other things, but we're close to having the finished design of the bike. So deliverables for this assignment. One drawing with a large isometric view, as big as you can get it on the page, so you can really see all the sub-assemblies. So this is going to be 5 total drawings. The second drawing is going to be an orthographic of the frame, front, top, right side view. Remember, the front view doesn't mean the front view of the vehicle. The front view is the main view. It shows the most information, longest dimension, fewest hidden features. So in this case, I chose this as the front. Top view, right side, and then do an ISO view. Again, make them nice and large on the page so they fit on there okay. Use a B-size paper, and then put some overall dimensions, height, length, and width. So that's the second. The third drawing that's due is a sub-assembly of the frame. Put it on a drawing sheet, put balloons and a parts list on that. Again, make it nice and large so it's easy to see. Fourth drawing is going to be a sub-assembly of the swing arm with balloons and a parts list. And you're probably going to need a couple of views so that you can show all the parts. Again, try to make them as large as you can. Make sure the parts lists are filled out with part names and or part numbers in the column that says number, and description is a written description of the items. Title blocks are filled out properly. And then the fifth drawing is an exploded view of that jack shaft subassembly. So that'll be the one that you've revised. It fits on the frame. It's got holes so it can attach to those mounting brackets on the frame and all the components. Again, balloons, parts list, everything filled out